Hi, welcome to online learning. Hey, let's look at Chapter 5 review. So if you haven't printed it off already, pause the video and go print it off because you're going to need a copy of it so you don't have to write down all the problems. The first part of it is a true-false part. So we're going to look at this. So the equation log base b of x equals y can be rewritten in exponential form, b to the y equals x. So I just look at this and say, how would I change this part to an exponential equation? I always start with the base. Log base b, so base is b. b, the power is the one that's alone. The power stands alone. So b to the y equals that number right there. So b to the y equals x. Yep, that one is right. Number 3, the domain of the function e to the x is greater than 0. Well, when you think about the graph of the function e to the x, it looks like this. It's increasing and it goes kind of like that. So it is not just greater than 0, it's all real numbers. So this one is false. Now if it would have asked about the range goes from x equals 0 and above. Or sorry, it would be y equals greater than or equal to 0. So that's the y part. So this one is false. The horizontal asymptote of the graph, blah, 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 is at y equals 4. When we look at this right here, this negative 1 would shift it to the right 1, and this would shift it up 4. Well, the horizontal asymptote would have been y equals 0, but now it's been shifted up 4. So the horizontal asymptote is y equals 4. So that one is true. If log base 2 of 1/8 equals x, then x equals 3. Well, I would change this to exponential form. So let's see if that is true. So the base is 2, so I would write 2 is the base. The power is what's standing alone, the power is x, but here it says that x is 3. So the power is 3, and that should equal 1/8. But that is not true. So this is false. Now, if it would have been a negative 3, because 2 to the third is 8, but that negative would have shifted the 8 down to the denominator, then it would have been okay. But as x equals positive 3, that's not right. The expression log of a to the third plus log of b to the fourth minus log c squared is equivalent to, now it's good to recognize that you have this plus thing going on, but then you also have a minus, so the a to the third would be times b to the fourth, and it would all be divided by c squared. But here's the kicker. It does not have the logs being divided. The properties only says that the numbers are being multiplied and divided. So if this would have been written like this, log of a cubed, b to the fourth, over c squared, then it would have been okay. But because of that 2 logs, the logs being divided, that makes the whole statement false. And the last one is kind of the same thing. Log base 17 divided by log 3. You think, oh yeah, that just divides out that way. But because of the logs being divided there, this makes that statement false. All right, let's look at the next section. So we're going to determine whether each function is an example of exponential growth or decay. So when you look at this right here, notice this has a negative x. Now one procedure or default you could do is to just graph it. And if it's increasing, going up, it's in growth. If it's decreasing, it's usually a decay. But even without graphing it, we can tell just by looking at the exponent, and where that's a negative exponent for the exponential function, that is going to make this whole thing a decay. The y-intercept for these functions right here, the parent function would be 0, 1, because it crosses at 0, 1. But where this is being multiplied by the 500, our y-intercept is then at 0, 500. And if you looked at a graph and you can't see the y-intercept, you could go to the table on the graph and see that when x is 0, y is 500. So that would also tell you the y-intercept. This one over here, number 2, the x is a positive number, so this is a growth, so G for growth, and the y-intercept is at 0, 3, because it's being multiplied by a 3. Number 3, asymptote, domain, range, and transformation. I'm going to start with the domain and range, just because if I can figure that out, the others kind of make sense to me. So this is an exponential function. It is a decay, but we still know that all exponential functions, the domain is all real numbers. So even though it's been flipped across the axes and up 7, the domain is still all real. The range, although, has been shifted up. And where that x has a negative in front of it, that means it's reflected across the y-axis. So if you think of it being flipped across the y-axis, so that's being flipped vertically, that's where the decay comes in, because it reflects it on the y-axis. So when we look at the range on that, the range would have been from 0 to infinity, but now it's been shifted up 7, so now the range goes from 7 to infinity. Now let's look at the transformations. So the transformations, again, because of that negative in the exponent with the x, then that means it's going to be reflected across the y-axis. And then also it's going to be shifted up 7. It also has an asymptote, and this is a typical exponential function. The asymptote of the parent function would have been y equals 0, but because it's being shifted up 7, the asymptote is now y equals 7. Okay, looking at number 4, we're still looking at an exponential function. So this negative 3 means it's being shifted to the right 3, and then the plus 1 also means that it's being shifted up 1. So our transformations would be right 3, up 1. And let's look at the domain and range. Because this is still an exponential function, the domain is all reals. The range, although because it's been shifted up 1, the range now goes from 1 to infinity. And then that also tells us that the asymptote is at y equals 1. Now one way you can tell that is because it's a horizontal asymptote, so it's y equals something. Vertical asymptotes are x equals. But then also it's the range that's affected, and the range is all the values of y. So the y equals 1. All right, now some opportunity for you to write an equation of a graph that has been transformed. So we're going to write an equation for G, and this is g of x. And we're going to take this function f of x, which is just the exponential function, and we're going to transform it according to this information. So the first is a reflection in the y-axis. Well, a reflection in the y-axis has a negative to that exponent, so it's going to be e to the negative x. That's what's going to make that reflection in the y-axis happen, followed by a translation 2 units down. So 2 units down is subtracting 2 from the whole equation. So that's what that equation would look like. 6 similar ideas, but just a little bit different. We have g of x equals, only this time the reflection is in the x-axis. So that means the negative is out in front of the function. So it's negative e to the x. And then also it says a translation 5 units left. Well, 5 units left means that we're adding 5 units to the x value of the function. So that's what number 6 would look like. Number 7, we're going to use this formula right here, a equals p e to the rt, and just replace it with what we know. So how much money will he have in 30 years? That's the value of a. That's what we're looking for, is a. We know that the original principal that he invested was $5,000. So that's what 5 is, or p is, 5,000. And then e to the r. R is 1%. We always change it to a decimal. So 0.01. And then time is 30 years. So be sure that you multiply those together. Now it's just a matter of grabbing a calculator, putting that in exactly as it looks. 5,000 times e to the 0.01 times 30. Make sure you multiply those two numbers together. And the answer is going to be in dollars. So we would round it to the nearest cent. So it would be $6,749.29. The next part, we are going to write exponential, change them to logarithmic forms. So I look at the base first. This has a base of 2, so I write log base 2. Make sure you show that it's a base, it's a subscript down there, of 32 equals the power. You always write the power alone over here. The power stands alone. So that's exponential form. This is logarithmic form. They mean the same thing, it's just a different form. Okay, same thing here. The base is 10. So I'm going to write log base 10. Because the common log is log base 10, I don't even need to write a little base 10 right here. You can if you want to, but you don't have to. So you have log of 100 equals 2. Last one, base e. So I'm going to write log base e, which is L of n, of 20.0855 equals 3. Sorry for the sloppy handwriting. Okay, the next one we're just doing the opposite thing. We're going to write it backwards. So we start with the base again. 6 is the base. Remember the power was the one that was all alone. So 6 to the third equals 216. This one, we start with the base again. So this is natural log, so it's base e. So we write e to the power of 0.693 equals 2. And the last one, we start with the base. Base is 1/2. We raise it to the power of -3, and it is equal to 8.